Okay. Okay, fine. So first thing is that, so you want to become like a data scientist, right? Even you are the become like a data scientist or data analytics. Okay. This could be the, life cycle of the project. Actually, this when you deal that, data science project or else a data analytics project. Okay. So these are the steps you have. This is the life cycle. Okay. So the first thing is that, you have to go and understanding the problem definition. And problem definition means it's a business requirement, nothing but. The second step is that based upon, for solving that particular business problem, so you should require some kind of data, right? So that we can call it such the data acquisition. So once a data is collected, then the next thing is that we have to prepare that particular data. After that one, we have to explore the data with help of various visualization techniques. Then we can start building the model, machine learning model. There we have to go for apply the machine learning algorithms in the in the third step. Okay. So in the fourth step, we have the model building, right? There actually exactly the machine learning will comes to the picture. Okay. So whatever the machine learning model we build, so that we have to evaluate it. So once evaluation is done, then we can able to go for model deployment. Then every time once the model is deployed, then every time we have to maintain that particular model actually. Okay, this is the data science life cycle. Okay, most of the people can call it as a crisp data science life cycle. Okay, clear?
Yes, clear.
Yes. Okay. So, Srija, are you following my point? So this is the life cycle of the
Yes.
project. So if you can choose any data science or data analytics project, okay? So these are the steps. This is the life cycle of the entire project. The problem could be anything. The problem statement, it could be anything, but this is the steps only we have to follow for the data science life cycle. Clear? And so, each and every step I explain in a clear way. So problem definition means it's, business requirement. You are started working like a data analyst or data scientist. Okay. Walmart. So, Walmart will give you some kind of business problem, right? You have to solve that particular business problem, right? That we are calling it, say, problem definition, identifying the business problem and opportunity that the project aims to address. That exactly we are calling it, say, problem definition. So once if you are understanding that problem statement or problem definition or business problem or business requirement, that all it could be the same pronunciation. I mean, same no pronoun. Clear? See, once if you are understood the problem definition or else business requirement, then the second step is that we have to go for collection of the data. So data acquisition and preparation means collecting the data and cleaning the data that will be used for further in our project actually. So so for solving this particular problem, as a data scientist, as a data analyst, as a data engineer, okay, you should work with the data, right? So the first step is that based upon the problem statement, we need to collecting the data. Once if we collected the data, it could be like structural format or it might be unstructured format. So that's the reason we have to go for apply the various data cleaning techniques. Clear? Once if you prepare the data, so the next step is that we need to go for analyzing the data. That means we need to go for understanding the data with the help of the various visualization techniques. Okay. So finding the underlying patterns and relationship between the variables, another variable. Okay. So that way you have to do some kind of visualizations like with help of the Tableau, with help of the Power BI, with help of the ClickSense or ClickView, various, visualization tools are there. With help of those visualization tools, we have to go for, we have to find the inside of the data. Okay. Clear, right? So is the third step is clear or not? So in the fourth
Yes.
step, we have to go for building the modeling building. So developing and testing the various statistical and machine learning models and to solving the problem statement. So business requirement, whatever the business requirement we have it. So now for solving that particular business requirement, you have a data. So once if we have a data, then with the help of the machine learning and various statistical techniques, we can able to build the model so that we can easily solve the business requirement. So as of now, that's fine. You build the model, right? But the model is whether it is good model or else bad model, whether it is fit or not. So how we can do that actually? So with help of the assessing the performance of a model and selecting the best one actually. So with help of the model evaluation, so we can able to go for finding the best model among the multiple models. So we are not, as a data scientist, as a machine learning engineer, as a data analyst, so you're not building only single model. You have to go for build the various machine learning models. Okay. From that particular all models, we have to go for, we have to go for finding the best model. So once if you're finalizing the model, then with help of various REST APIs or else application program interface or else various frameworks, okay, we can deploy the model into the production. Okay, so once if your evaluation is done, our model is good and it is performing well, then we can deploy that particular model into the production environment so that it could be available for the end user. Once it is available for the end user, so in a real-time scenarios, we have to continuously monitor it. So if you're not continuously monitored, maybe because of seasons or because of any other situations, okay, your model cannot give you the good predictions. So that's the reason. So we have to continuously monitoring and updating the model to ensure it's to stays accurate and relevant over the time. So that is the exactly the maintenance is doing. So for maintaining this particular existing model, so you don't need much experience in the data science actually. So very minimal experience, even junior level data science guys can easily maintain that particular model because you're not building end-to-end machine learning model. We are just always monitor the model. So for that one, very a base a very less experience like entry level positions. Okay, so you can fulfill it. So this steps is mentioned above in general step in the data science life cycle, and it might be some variations depending on the specific problem and the data and organization. So usually this is the steps that could be followed in any everywhere, but sometimes it can be changed. But overall thing is that in a general way, these are the 7 steps. These are the 7 steps actually. Okay. These are the 7 steps we have to follow to build the best model, the best machine learning model for solving the any artificial intelligence application, for any deep learning application, for any data science applications, whatever it is. Okay, wherever machine learning is there. So basically, these are the steps could be involved. Clear? Is it clear or not?
Yeah, it's clear. I just want to mention something for step 2.
So steps
Uh,
2. Okay. Yes,
yeah,
yes, I would
step,
like to
step,
go. Yeah,
yeah, step
just a minute.
2 here will take us 80% of the job we're gonna do.
No, no. I just
The,
I will give you some kind of real time example so that you can easily understand. Okay.
okay.
So for example, I am working for example, one insurance company. Okay, insurance company. Okay, so this is insurance. You are working for any one of the insurance company. Okay, so here the insurance company, they come up with the problem statement is that, okay, predict the, okay, fraudulent or else predict the customer is will get the insurance or not. Predict the customer is fraudulent or not. This is my problem statement. Is it clear my question? You're working for
Yeah,
insurance company. Okay, so here the use case is that predict the customer is fraudulent or not. In general, most of the customers, what they will do actually, even they are not eligible for the
hey,
insurance, even they are not eligible for the insurance. Okay, Whether the customer will get the insurance or not, even fraudulent or whatever it is. Yeah, Bruno, can you please listen the my points?
Okay.
Bruno, are you listening or not?
Yes, I'm listening.
Yep. So you are working for one insurance company. Okay. So the insurance company, they're facing a lot of issue. So most of the customers are doing fraud. Okay. They're not actually not eligible for the fraud. They're not eligible for the insurance, but they're applying the insurance, and because of the fake documents, they are getting that, insurance actually. Because of that one, the insurance company, it was, going loss, right? So to overcome that one, okay, they hire me, or they hire you as a data scientist, and they given a use case for you, predict the whether this customer is a fraudulent or not. That is a use case. Clear?
Yeah, clear.
For that one, as a data scientist, what exactly the first question is, do you have the data? Okay, do you have the customer data? So previous existing historical data. Do you have the historical data or not? Okay. So this is the first question you have to ask to your client. Okay. The client will give you answer is yes or no. For example, if the client was given the answer is no, if you don't have a data, then how you can build the model, right? If you want to build the model, or if you want to solve any business, any data related project, okay, so you should have a data. So by the time, if you don't have that historical data, okay, like so you should have some group of fraudulent people, and genuine customers and fraudulent customers, you should have that particular data actually. If you don't have that particular data, then what you should do actually, so we need to collect the data. Okay, by the time of collecting the data, so we might be use some kind of third party data. Okay, like, so usually some people, some agencies will sell the data actually. Okay, so third party, we have to buy the data from the some third parties. So the data what they given, which is not in a, it was not in a structure format, or else there could be some kind of missing data. There are some kind of issues in this particular data. Okay, what data you collected from that part, the third party, okay, there are some, some issues in the data. Okay, so that, in the second step, you have to handle these issues. Okay, you have to handle the that specific issues. Is it clear or not? So this is exactly the second step. Clear? And anyway, finally you are collected the data, and sometimes if you don't have a data, then what happens? You have to collect the data, and we need to process the data, or we have to handle some kind of issues actually. Okay, so even though you have some kind of data, so even you have a data, so this is the step is common. Okay, there could be some kind of issues are there, whether if we have any kind of issues, then we need to go for handle that specific data actually. Clear? And we need to handle that all kind of issues. That is exactly the second step. Clear? That exactly the second step. In the fourth step, what we can do with help of some kind of visualization techniques, okay, like Tableau, or else with help of the Tableau, or else Power BI, okay, you can do some kind of graphs. You can create some kind of graphs or maps. Okay, with help of that one, okay, you can easily understood the data, what exactly the data is talking about. So is there any kind of, if the data is misleading, or else we can explore the data. If you want to explore the data, for looking the data in a text format, it's impossible to understand. So that if you have some kind of visualization techniques, then you can easily understood the graphs or maps, and so that visuals. So with help of that visuals, then we can easily, you can easily understood that entire data. Clear? That exactly the next step. Then of course we have to go for building the various machine learning algorithms, and we have to go for finalizing the model with help of and performance testing. Like evolution is nothing but so which model is good or no, which model is fitting best, and which model is not giving good results. So that everything we have to evaluate it, then we can deploy into the production in the sense, it might be how deploy into the cloud, or else on premises. and so that everyone can able to access that particular models. Yes, of course, we can use the Python for visualization. Bruno, of course, we can use the Python for visualization. Okay, that exactly the data science life cycle. Clear? So here I just show you some kind of some real time use case. So whether the customer is fraudulent or not, that it could be the real time use case. Clear? See, for solving this kind of problems, okay, so make sure that you should have good knowledge and good experience in the, okay, so machine learning. So that this particular class, we are talking about machine learning actually. Okay, I hope you understood the data science life cycle. Data science means prediction of the future with help of some historical data. So first we need to go for understand what exactly the data science. Data science or data analytics is nothing but it's a field of the data. So now what exactly you will do? What exactly will do? Okay, predicting the future with help of okay, historical data. Historical data. Okay, predicting the future with help of the historical data. See, here my use case is that, predicting whether the customer is a fraudulent or not, that I want to predict. Okay, or else whether the, a patient will get the diabetes or not, that is also one prediction. Whether your mail is spam mail or not, that is also one prediction. Okay, and whether the stock value can increase, my share value can increase. You are investing into one specific company. I want to buy the share value, or I want to buy the shares of one particular company, right? So whether this particular company will increase or not in the next few years, that I want to predict. So wherever the future prediction is there, that concept we are calling it's a data science, predicting the future with help of historical data. Okay, so how you are going to be predicting the future? So for that one, we would like to go for using the various technologies. It could be machine learning. It could be machine learning. It could be deep learning. Okay. And so with help of the machine learning and deep learning, or else artificial intelligence in the sense, the combination of the machine learning and deep learning only. Okay. With help of the machine learning and deep learning algorithms, with help of machine learning and deep learning algorithm. And so here we have historical data. So with help of historical data, we can train the machine learning and deep learning algorithms. The model, you can use it for predicting the future. Okay, that exactly the machine learning use case. Okay, so why the machine learning is required? So to build the machine learning algorithms, or to build the machine learning models, to build the deep learning models, we require machine learning and deep learning knowledge. Okay, so that let's go for understanding the first machine learning, then we can talk about the deep learning. Clear? Let's go for understanding the machine learning. Machine learning in the sense, the mission or else software or algorithm is learn itself. It can learn itself, okay, without any explicit program. Explicit program in the sense, you don't need to write some external program actually. Okay, so mission or software algorithm, it can be learned itself without any explicit program. Is it clear? So I just want to give some example actually. Okay, for difference between the machine learning and traditional program and machine learning program. So here we have a draw. Okay, yes, fine. Okay, let me take it. Let me take this example. Let me take some example actually. So this is my, okay, this is my old program. Okay, so this is my program. I written the code with help of the Python. So this is my program. So this program, Okay, you have to give the inputs. Okay, here input 1 and this is my input 2, right? Okay, so it will be producing output, right? Yes or no? So if you have any program, it could be C program, Python program, Java program, what exactly it will do? It will take the inputs from you and process it and getting output. Is it yes or no? This is traditional program. It's a traditional program. But when it comes to the Python program, what exactly it will do actually? Okay, this is my ML algorithm. ML means machine learning algorithm. So here we have some kind of set of inputs. Here we have some kind of set of inputs and the corresponding outputs. Okay, here we are providing input and output to your machine learning algorithm. Then this is the machine learning algorithm. It will producing the program. It will produce the program. Is it clear or not? Did you get the difference between the ML program and traditional program? Everyone? Srija? Ramu?
Yes.
Yes. In traditional program, simple thing. So you have some kind of inputs and you want to you have to get output. For that one, we have to write the program. Okay. So the logic you should implement it yourself. But here you have to give you some kind of set of inputs and corresponding output. The program, the machine learning algorithm, it can be generating output as a program. Let me give some example. So here I have a data. Okay, this is my data. So this is my data. So this is my x1 and this is my x2 and this is my output. Okay. So here x1 is 2 and x2 is 3 and output is what? For example, 6 and 4 and 8, 32. Okay. For example, here we have the what do you call 10 and 20. What is output here? It's a 200. Okay. See, these are the two things we can call it say inputs. Okay, this is the thing we can call it the output variable. Okay, so this is x1 input and x2 is also input. So that means x1 column, x2 column, we can call it as the features. So these two things we can call it as the independent variables. What it is? Independent
Variables.
and so this is the variable we are calling it a dependent variable. Clear? So these two variables we are calling it say independent variable. This variable we are calling it say dependent variable. Clear? So or else we can call it as the feature variables. So different names, and this variable we can call it response variable, or these are the things we can call the predictors, and this is predicted. Okay. So anyway, you can have different names actually. Okay, you might have the different names. I'm not talking about those names and other things actually. You can simply remember it input and output. Okay. So this is my data. So this is my data actually. So for this particular data, what I can do, I have the machine learning algorithm. Okay. I have the machine learning algorithm. This is the data I am giving to the machine learning algorithm, the algorithm which is producing the program for multiplication program, because this here 2 into 3 6, 4 into 8 32 and 10 into 200, right? So which is generating the program or which is generating the model? The model is multiplication model. Okay, this is the model we are calling it say multiplication model. So in future I'm giving the some new inputs. I'm giving some kind of new inputs. For example, 5 is my new input and 6 is my new input. What could be the output it can be producing? 5 into 3, 5 into 6, it's a 30 or not? So this is the program you are not creating. This is the program which is created by the machine learning algorithm. Clear or not? In future, this model, you can give it for finding some kind of new things, unknown things. So I don't know what exactly the value of 5 into 6. So if you give the 5 into 6 to your multiplication model, which is producing 30. I hope you clear my point. Srija, Ramu, and Bruno, can you please respond in the chat, or else you can unmute your system and you can.
Yes. Yes, Anand.
Okay. Okay, fine. So I would like to talk about deep learning after I completed all machine learning concept actually. Okay. And but so the main difference between the machine learning algorithms and deep learning algorithms are, so for machine learning algorithms, okay, so here it could be work on a mathematical model, statistical model. Okay. So there you should have some kind of input data and output data. Okay. Then only it will work in a proper way. Okay. So but in case of deep learning, it's how human brain is thinking and how human brain is learning itself. In the same way, you can creating the models actually. Jeffrey Hinton is the father of the deep learning. So that we will talk in a later on sessions. But this time we would like to go for concentrating on the only machine learning. Okay. So this time we would like to go for concentrating on the machine learning. So we'll talk about the deep learning concepts after this, after I completed all machine learning methods. Okay. Okay. Now, I would like to talk about the machine learning, right? You understood what exactly the machine learning. So basically, this machine learning is totally 3 type of machine learnings are there. How many types? 3 types.
3 types.
The first one is the supervised. Second one is unsupervised. Okay, unsupervised machine learning algorithm. Third one is the reinforcement. Okay, so have you got my point? So basically, we have the 3 type of machine learning algorithms are there. The first one is the supervised, and second one is unsupervised, and third one is the reinforcement. The main difference between these 3 is, here we have the input variable and output variables. That means you have a data, both input and output. Okay. But coming to the supervised, we have a data. It doesn't have any specific like input data and output data. Okay. There is no any segregations. We have some kind of data. That's it. So from that one, we have to cluster it. We have to make it some kind of groups. Here, no data. I hope you understood, right? The difference between the supervised, unsupervised, and reinforcement. In reinforcement machine learning algorithm, when you don't have the data, that situations, you want to build the model, then you have to choose the reinforcement machine learning algorithm. Okay. So if you want to build any artificial intelligence applications, without reinforcement, you can't imagine any single program. Okay. And coming to the unsupervised data, here you have a data. It doesn't have any kind of output variable. That means there is no labeled data. Okay, you have enough data actually. You have a data, but from that particular data, we have to categorize it with similar features. Okay, so we have to make some kind of groups from that particular data. That means if any data, it could be having the same group. We have to make it like some kind of clusters. This is one group, and this is one group. This is one group. This way, we can make it some kind of groups from that particular entire data. But when it comes to the unsupervised machine learning algorithm, we have enough data and it could be having some kind of input variable and output variable. And next one is coming to this particular supervised. Again, we have the two types of data, two type of machine learning algorithms are there. Okay, what are those? What are those? Regression. First one is regression. Second one is classification. Okay. See, here we have output variable, right? Here we have output variable or not? So this output variable, it could be number. It could be a number or else it could be category. Category in the sense like yes or no. Previously, I given some kind of use case, right? Whether the customer is fraudulent or not, that it could be category or not. So when it is the category, then we can choose the classification machine learning algorithm. When my output variable is a number, for example, I want to predict the stock value of one particular company. Stock value, there it could be a number. When my output variable, it could be having the number data, then we can choose the regression based machine learning algorithms. Clear? So one more time, I would like to go for explain you guys. So listen carefully. So here we are talking about machine learning. There are three type of machine learning algorithms are there: supervised, unsupervised, and reinforcement. Coming to the reinforcement, when you don't have data, that situation, we can choose the reinforcement. You have unsupervised data. Unsupervised in the sense you have some kind of data, but you don't know what you want to predict. So by the time we can make it some kind of cluster with help of the unsupervised machine learning algorithm. So finding the similar features and make them as a one group. So with help of that one, the unsupervised machine learning algorithm can be work. And coming to the supervised machine learning algorithm, there we have some kind of input variable and output variables. But here depends upon the output variable. It was two type of supervised machine learning algorithms. The first one is the regression. Second one is the classification. Coming to the regression, when my output variable is number type, then we have to choose the regression based machine learning algorithm. When my output variable is the category type, then I can choose the classification type. It's a binary classification, again, multi-classification. Again, classification also, we have a different type of classification techniques. Even in a regression also, we have the different type of regression concepts. We have regression algorithms. Coming to the regression, we have the linear regression, simple linear regression, and multiple linear regression, polynomial regression, linear regression, and random forest regression, and decision tree regression, and lasso regression, and ridge regression. Like we have various regression based algorithms we have it. So we have when we have output variable is a number, then we can choose this all regression based machine learning algorithms and build the model from all the model, which one is the best one that we have to finalize it. Coming to the classification machine learning algorithms, we have the we have like we have the logistic regression. Okay, logistic regression, and we have KNN regression. Okay, KNN, not KMM, KNN, support vector mission, and decision tree classifier, and random forest classifier, XGBoost classifier, AdaBoost and XGBoost, various boosting and bagging, Navibase. Okay, Navibase algorithms. So like we have various classification types we have it. So this module, especially we are targeting only regression, classification, unsupervised. Okay, that's it. Any questions, guys? Any questions? Srija, Bruno and Ramu. If you have any kind of question, please let me know. I would like to try to answer you.
No, Arjun.
Okay. So by tomorrow's session, what we can do actually, so we'll talk about linear regression and multiple linear regression, and theoretically, practically, and assumptions and the evaluation matrices. Everything we'll discuss by tomorrow's session with a project. Okay. If someone having a knowledge of some basic knowledge of the Python, you can easily build the any machine learning algorithm with help of the Python. You don't need to worry about it. You don't need to much coding knowledge. Okay. So with even you have a small enough knowledge in Python, you can easily start building off any machine learning algorithm. Okay. Clear? So guys, let's meet tomorrow for understanding the linear regression and multiple linear regression theoretically, practically, with the project. Okay. See you.
Okay.
Take care. Bye.
Thank you, Arjun.
Bye, Bruno. Bye, Ram.